Welcome back to the course. This is Introduction to Azure Networking, and this is Lesson 11, where you'll deploy your second Azure VPN, this time using point-to-site. By way of introduction, just a quick recap that links to the prerequisites for the course can be found in the Introduction section, and links to the deployment scripts, which are hosted on GitHub, can be found in the Resources section. This lesson comprises two parts. In Part 1, you'll learn how to create a resource group to represent a fictitious home user to further split our deployment across multiple containers for better organization, how to create a network security group and a virtual network with one subnet to provide connectivity for the virtual machine, how to create a public IP address and a network interface attached to the subnet, and how to create a virtual machine using the network interface and a Windows desktop operating system image. In Part 2, you'll learn how to update the virtual network gateway to configure the point-to-site VPN, how to update the local network gateway for the hub to advertise the point-to-site VPN address pool over the site-to-site VPN to the data center, how to connect to the Windows virtual machine over the internet, install the point-to-site VPN client and import the point-to-site VPN configuration, and how to connect to the point-to-site VPN and validate connectivity to both the hub and spoke topology and to the data center via the site-to-site VPN. Let's review the topology diagram for this lesson. First, let's recap on the resources that we're reusing from the previous lessons. These include the hub resource group, its virtual network, along with the virtual network gateway, the bastion, the firewall, the peering relationships to the spoke virtual networks, and the site-to-site VPN to the data center. We're also reusing the first, second, and third resource groups, their virtual networks, their virtual machines, and their peering relationships to the hub. And lastly, we're also reusing the data center resource group, its virtual network, along with the virtual network gateway, the virtual machine, and the site-to-site VPN to the hub. We now also have a resource group to represent the home user, a virtual network with one subnet, and a virtual machine and its associated resources attached to the subnet. In the second part of the deployment, we'll add the point-to-site VPN configuration to the virtual network gateway in the hub, and we'll update the local network gateway for the hub so it advertises the point-to-site address pool over the site-to-site VPN to the data center. And now, let's see what this looks like in the Azure portal once everything's been deployed. Here we are in the Home Resource Group view. From the top, we have the network security group associated to the subnet. We can then see the virtual machine and its operating system disk, the public IP address and the network interface. And finally, we can see the virtual network to which the virtual machine is connected. In the Hub Resource Group view, we'll update the virtual network gateway to configure the point-to-site VPN. And finally, in the Data Center Resource Group view, we'll update the local network gateway for the hub to advertise the point-to-site address pool over the site-to-site VPN to the data center. Now it's time for our demonstration, so let's get started. Here we are in Visual Studio Code. We have the first deployment script open and our terminal is ready. Before we review the script, just a quick side note here. This deployment will look familiar because we've made some very minor adjustments to the same script we used in Lesson 1, where we deployed our first virtual machine. We've amended the naming convention and address prefixes used for the home user resources. We've associated the network security group to the subnet instead of the network interface. We're allowing inbound RDP traffic to the virtual machine instead of SSH. And we're using a slightly larger virtual machine size to accommodate a Windows operating system image. Whilst the approach of scripting our deployments in this way in terms of infrastructure as code would be considered imperative instead of declarative, hopefully you can continue to see the benefit of reusability in performing our deployments programmatically instead of within the portal. As usual, before we execute the script, let's review it so we can understand what it's doing. From the top, we have our variables. We're going to create a resource group, so we need its name and its location. We're also going to create a network security group and a virtual network with one subnet, so we need their names and their address prefixes. We'll create a virtual machine, so we need its name, along with the names of its public IP address, its network interface, and its operating system disk. We're going to use a slightly larger virtual machine in this deployment, so we've updated the size. We're also going to use a Windows virtual machine this time, so we've updated the image. And finally, we'll reuse the username and password that we've used throughout the lessons so far. Now we have our variables defined, we can begin creating our resources. First, we'll create the home resource group. This requires its name and location. Next, we'll create the network security group. This requires its name, resource group, and location. We're going to permit inbound RDP traffic to the virtual machine from our public IP address, which we can obtain using the familiar invoke web request commandlet to the IP info API, which we'll store in a variable. We can now create the security rule. This requires the name and resource group of the network security group, along with a number of other parameters. These include the name, direction, and priority, the parameter to allow access, the source and destination address prefixes, and the protocol and port. Note here that we're using TCP port 3389, the default for RDP, instead of SSH. Next, we'll create the virtual network. For this, we just need its name, resource group, and location, along with its address prefix. And now we can create the subnet. For this, we need the name and resource group of the virtual network, along with the name and address prefix of the subnet, and the name of the network security group. We can then create the public IP address. For this, we need the name, resource group, and location, along with the SKU and allocation method. Next, we can create the network interface. This requires its name, resource group, and location, along with the name of the virtual network, the name of the subnet, and the name of the public IP address. And finally, we can create the virtual machine, for which we need its name, resource group, and location, along with several other parameters, including its size, its username and password, its operating system image, the name of the operating system disk and its associated SKU, and the name of the network interface. We can now execute the first script, which will deploy the resources. Here we are again, back in Visual Studio Code, this time with our terminal window maximized. Let's execute the first script and observe the deployment. If you're following along, in a moment you may wish to pause the video here until the deployment is complete on your side. Now our first deployment is complete, let's change over to the Azure portal to review our resources. Here we are in the Azure portal, in the Home Resource Group view. Let's review the virtual network. Under Settings, we'll review the address space. Here we can see that we're using the 192.168/16 address prefix, which does not overlap with any of the address space used elsewhere within our topology. If we review the subnets, here we can see that we have a single subnet allocated the 192.168.1/24 address prefix. Let's go back into the resource group view, and let's review the network security group. Here we can see that we're restricting inbound RDP access to our public IP address. Let's go back to the resource group, and let's review the virtual machine. Here we can see that the virtual machine is running. It has 2 CPU cores and 8 GB of memory. It's connected to the subnet within our virtual network, and it's allocated the private IP address of 192.168.1.4. We'll copy the public IP address to our clipboard, as we'll need this in a moment to be able to connect to the virtual machine over the internet. Now that we've reviewed our resource deployment, let's return to Visual Studio Code to review the second deployment script. Here we are back in Visual Studio Code. We have the second deployment script open, and our terminal is ready. As usual, before we execute the script, let's review it so we can understand what it's doing. From the top, we have our variables. In the hub, we're going to be updating the configuration of existing resources, so we need the name of its resource group, along with the name of the virtual network gateway. We also need the address prefix that we're going to allocate to the point-to-site VPN address pool, along with the address prefixes of the 3-spoke virtual networks from the hub and spoke topology. We're also going to be updating the configuration of existing resources in the data center, so we need the name of its resource group, along with the name of the local network gateway for the hub, and the address prefix of the hub virtual network. The rest of our variables will be dynamically generated throughout the remainder of the deployment script. To be able to set up Entra ID authentication to the point-to-site VPN, we need to retrieve our tenant ID. We can do this using a show command, with a query filter for the tenant ID, storing the result in a variable. We can now construct the necessary variables which we'll use when setting up Entra ID authentication. First, we need the login endpoint for our tenant. This is at login.microsoftonline.com, followed by our tenant ID. Next, we need the secure token service endpoint for our tenant. This is at sts.windows.net, followed by our tenant ID. And finally, we need the generic audience ID. This is a publicly available string directly from the Microsoft documentation. We can now configure the point-to-site VPN on the virtual network gateway. This requires the name and resource group of the virtual network gateway, along with a number of other parameters. These include the login endpoint, secure token service and audience ID for our tenant, which we've just initialized into variables, the parameter to enable OpenVPN client protocol, the address prefix to use with the VPN, and the address prefixes of the spoke virtual networks within our topology, which we want to be routed over the VPN. And finally, we can update the local network gateway of the hub to advertise the address prefix of the point-to-site VPN over the site-to-site VPN to the data center. For this, we need the name and resource group of the local network gateway, followed by the address prefixes of the hub, the first, second, and third spoke virtual networks, and the point-to-site VPN address pool. We can now execute the script, which will deploy the resources. Here we are again, back in Visual Studio Code, this time with our terminal window maximized. Let's execute the second script and observe the deployment. If you're following along, in a moment you may wish to pause the video here until the deployment is complete on your side. Now our second deployment is complete, let's change over to the Azure portal to review our resources. Here we are back in the Azure portal in the Hub Resource Group view. Let's review the virtual network gateway. Under Settings, we'll review the point-to-site configuration. Here we can see that we've allocated the 10.96.0/24 address prefix to the address pool. We're using the OpenVPN tunnel with SSL. We're using Entra ID for authentication. We've specified the login endpoint, the audience ID, and the token endpoint for our tenant, and the address prefixes of the spoke virtual networks within our topology. While we're here, let's download the VPN client configuration, as we'll need this shortly to configure our Windows 11 virtual machine. Let's now switch over to the Data Center Resource Group view. Here we are in the Data Center Resource Group view. Let's review the local network gateway for the hub. Here we can see that, in addition to the address prefixes of the hub and spoke topology, we are now also advertising the address prefix of the point-to-site VPN. Next, let's connect to our Windows 11 virtual machine to install and configure the VPN client. Here we are connected to our home user Windows 11 desktop. First, let's allow ICMP echo requests in the Windows firewall, as we'll need the virtual machine to respond to a ping request to be able to validate connectivity. To do this, we'll open a PowerShell prompt. We can then enable the built-in rule to allow ICMP echo requests using the set net firewall rule commandlet. We can now minimize the PowerShell prompt. Next, let's copy the point-to-site VPN client configuration file from our local machine. We'll open File Explorer. We'll then navigate to this PC. And we'll browse to the redirected folder on the local PC. And then into the Downloads folder. We'll now copy the zip file to the Downloads folder on the Windows 11 VM. And we'll extract the contents of the zip file to the Downloads folder on the Windows 11 VM. We can now minimize the File Explorer. Next, we'll install the VPN client. To do this, we'll launch the Microsoft Store. We'll then search for the Azure VPN client. To install the client, we'll choose Get. And now the client is installed, we'll open it. And next, we'll import the VPN configuration. We'll choose the plus sign in the bottom left-hand corner of the VPN client, followed by Import. We'll then browse to the Downloads folder, into the Virtual Network Gateway folder, and into the Azure VPN folder. We'll choose the VPN configuration file. We'll then choose Open. We'll accept the defaults, and then we'll save the configuration. And finally, we'll connect to the VPN. We'll choose Connect. We'll then log in with our email address. We'll enter our password and choose Sign In. And we'll complete our MFA challenge. For our demonstration, we only want to sign into this app. And here we can see that we've completed authentication and that the VPN connection is established successfully. We can also observe the IP address assigned to our VPN client and the routes that have been advertised over the VPN. We can now minimize the client and validate connectivity over the VPN. We'll restore our PowerShell prompt. And let's try to validate connectivity to the first virtual machine. Here we can see that we've received a response to each of our requests. Let's now try to connect to the first virtual machine. And here we can see that we've successfully connected to the first virtual machine. From here, let's connect to the virtual machine in the data center. And here we can see that we've successfully connected to the data center virtual machine. From here, let's validate connectivity back to the Windows 11 virtual machine. Here we can see that we've received a response to each of our requests. Let's now try to establish a connection to the default RDP port TCP3389 using the netcat command. Here we can see that we've successfully connected to the Windows 11 virtual machine. Just a quick side note here, both the point-to-site and site-to-site VPNs are directly connected to the virtual network gateway in the hub. In this case, traffic between the VPNs will therefore bypass the Azure firewall. If this were a real-world scenario, consider whether it's appropriate for point-to-site clients to be able to connect across the site-to-site VPN and vice versa. If you don't want to permit this traffic, then you can either omit the point-to-site address prefix from the local network gateway that represents the hub to prevent the route being advertised, or alternatively, if you want to permit but control this traffic, then you could filter it on the on-premise VPN appliance or firewall where it enters your on-premise network. That concludes this lesson. Thanks for watching, and I look forward to seeing you next time.